This integration by parts for the second function. We are here in this video to teach you how to integrate arc sine x dx. In integrating this, to make it easy to do, let's try to rewrite it in form like integral arc sine x to multiply 1 dx. So in the process, arc sine s can be u, 1 can be v. So this will now make us to have the formula for integration by part to have integral uv dx, which give us u integral v dx minus integral du dx integral v dx. So total dx. So therefore, and we will be able to know the value of u and v. So we have our u is arc sine x to integrate 1 dx minus integral u, that is, and our u is arc sine x, now integral 1 dx or dx. So therefore, we have arc sine x dot x minus integral. So the moment you integrate arc sine x, it will give you 1 over the square root of 1 minus s square dot x or total dx. So you try to make x to come to the back to have arc sine x minus integral x over root 1 minus s square dx. Now, integrating this, let's try to represent, let's call this one I1, to integrate x onto the square root of 1 minus s square dx. So let's try to battle with this. Getting the value of I1, you bring it back to the equation. So in integrating this, let y is equal to 1 minus s square. Let's differentiate y with respect to x. We have minus 2x. Let's try to make the x as the subject of the formula, whereby we have, from here, we have dx is equal to dy to divide minus 2x. Recall, in this equation, where I1 is equal to integral x over square root of 1 minus s squared dx. So therefore, the integral x onto square root of 1 minus s squared dx, let's try to substitute back to have x over the square root of y to multiply dx will now give you dy to divide minus 2x. So now, you can be able to discover that x will cancel x, will give you integral dy onto square root of y to multiply 1 over minus 2. So let's try to bring this 1 over minus 2 to the back of dy onto square root of y. In integrating the reciprocate of the square root of y, we have 1 onto minus 2 to integrate y onto minus half dy, which will be minus 1 over 2 dot y onto minus half plus 1 to divide y onto, to divide, so to divide minus half plus 1. So, in view of this, we have minus half to multiply y raised to power half to divide half. By the time it divides half, it will now turn by reciprocal. It will be 2 to multiply minus 1 over 2 to multiply y raised to power half. So this we cancel this, telling you that I1 give us y raised to power half, which is equal to square root of y. So minus, there is a minus here. You have a minus y. Recall that integral arc sine x 1 dot dx that we try to integrate, it gives us x arc sine x minus I1. Now, plus constant. This should be our answer. So therefore we have x into integral x minus, this is only for this, the square root of y plus c. Recall that our y is equal to 1 minus s squared. If you can still remember, therefore, the integral arc sine x dx, which is equal to x arc sine x, now minus times minus plus square root of y, and our y is 1 minus s squared plus c. So this is the final answer for the integral of arc sine x. Try to share this video and follow this page. Thanks for watching.